And we are placing in primary cementing jobs, we are placing slurry between these two, like between hole and casing, or in the casing annular volume, okay, annular section. It's called annulus. Casing and deep water capacity. So volume we can store inside casing or inside drill pipe. It's called the capacity, that how much it can get. How we calculate it, I will show you. We are using ID, internal diameter of casing and drill pipe, to calculate what is the capacity of drill pipe in specific section, in specific height. Pre-job circulation, mud circulation. Why we are using pre-job circulation? Usually we are using it before cementing job. We want to clean the well, because we can have a cuttings after drilling. We can have a small parts of drill string, BHA, I don't know, debris inside the well, and we want to have well clean. And that's why we are using pre-job circulation. It also helps us to get BHCT, bottom hole circulating temperature. It cools down bottom hole, and we can do better cementing job in lower temperatures. Post-job circulation, it will be specific for some of cementing jobs for liner inner string. We will cover it, but it is just after we are placing slurry, we are doing post-job circulation to clean the drill pipes, to pump excess slurry out. Liner hanger. So you know probably what is liner. Sometimes we don't use long strings to the surface. We are using liners. It is hanged from previous casing. We have a liner overlap, which is starting from previous chute till the liner hanger. This is called a liner overlap. We need to have a good cemented liner overlap. Okay, liner hanger will be the depths. Liner hanger depths will be the depths we are hanging liner, top of liner. This specific system is called liner hanger. We have drill strings. It is the drill pipe, and in the end we have a BHA. We have under reamer, collar. We can have a heavyweight drill pipes. Okay, whatever inside BHA and whole drill pipe, it's called a drill string. And we run in whole drill string. We pull out of drill string. Then fluid density. So why I mentioned about fluid density, probably we will have a calculations, and we will need to use some SG, PPG. We need to know the differences in units. And also for fluid density, important point is surface density and downhole density. So surface density and downhole density is the same for, we assume it is the same for incompressible fluids. But when we have a compressible fluids, density in surface and the downhole is going to be different. For example, incompressible fluids, water is incompressible. We can't compress. I mean, maybe we can compress, but it is very small value. That's why we don't count it. We just say, okay, it is incompressible. And slurry is also incompressible because 99% of slurries are water-based, and that's why it is incompressible. There are some applications of oil-based slurry and other type of slurries, but it is very uncommon, so you will not probably hear about this. Yes, but mud, there are two types of muds. There are a lot synthetic and others, but mainly we divided two parts: oil-based mud and water-based mud. Water-based mud is incompressible, and when we pump water-based mud before cementing job, we know that it will be incompressible, and we can get its density as in surface. But when it is oil-based mud, downhole rheology and downhole density will be very important because it will affect ECD. Now, what is ECD? ECD is equivalent circulating density. And in the next slide, I will talk more about this ECD. So it is, we have a pressure after we have a pressure generated from pumping, right, in bottom hole. And when we convert this pressure to, when we use these depths and convert to this pressure to one density, one weight, it will give us equivalent circulating density. And it is usually higher than what we are pumping in surface. TVD, MVD, probably you know that in cementing slurry calculation, we are using MVD. So TVD is true vertical depths, MVD is measured vertical depths, and we are using MVD because our casing is going through NVD, and we need to cover, we need to have a zonal isolation through that casing. Okay, please, can you ask me questions if you have any question from this part, or everything is clear for you? Hello.
So guys, feel free to ask questions, or if you want, you can drop your questions in the chat. And
yes, I will also.
yeah, and our speaker will respond.
Okay, I got a comment that it is clear. So if no one has any question, then I can continue with more cementing related part. I just wanted to be sure that you all aware about this terminology. So, and I will have some information about casing. I will not go to casing specifications. I will just go through that borehole construction and how we determine, not we actually, I'm cementing engineer, but drilling engineers, how they determine sections, intervals in the well, okay? From scratch, why we drill a well? Because we have a target, okay? Sometimes it is called TD, target depths, or final well depths. So if you see my, let me see if you can see my pointer. Okay, don't see my pointer. Let me see how I can show my pointer here.
If you are doing some presentation, there is like an option to do that.
Okay,
in
here it
PowerPoint.
should be like, okay, wait, pointer here, yes. I can, but it should be option. It's automatic. Okay, visible. Now you see it, right?
I see the pointer.
Yes, the just pointer is okay. I just want to show with that. So here, okay. I guess I get it late in my phone. Okay, now there is some delay between my speech and I guess what I show. So here it is the target point that you want to go. What is target? Probably it is reservoir, right? We have our reservoir engineer said that, okay, we have an oil there, or we are expecting any gas reservoir, and it is our target point that you need to reach there. But how? Because we cannot go through one well bore in a time. We can drill till the end, because usually wells here in Azerbaijan is around 4,000, 5,000 meters, what I have worked. And in Angola, we had a wells with 3,000 meter MVD, I mean. So 3,000 meter, but at that time we had a 1,005 meter of water depth. It was deep water, real deep water, not fake ones. Here, deep water operations, we have 150 meters, so I can't call it deep water. It is deep water in paper, but main deep waters are in ocean. So in ocean, if you have a higher water depths, then you get well depths around 3,000, 4,000 meters. But in Azerbaijan, the current project I am working, our TD is more than 6,000 meters, more than 6 kilometers. So you cannot go through one wellbore in a time to this target depths, because we have a lot of different formation layers. From geology, you should know that we have a sandstone layers, we have a shales, limestones, and we have a surface water zone, shallow water zone, we call it, and some parts we have a shallow gas zones. In the bottom, we have a reservoir, we have a condensate, oil, gas. We have a formation fluids, right? So if we drill just once, if we can, it's not possible technically because of pore pressure and frac pressure gradients. Pore pressure and frac pressure gradients profile of this is coming from geologists, from their estimation, from nearby wells, from history, and they have some logs in exploration wells, so they can give us geological data, and they are telling, okay, for pore pressure, you have this graph. I will show you, and here I can, well, I guess I need to open my camera here, and I need to close Teams camera just to write down it. Please give me a minute. Okay, this is on. Teams camera should be closed. Rahima, would you please let me know when you see what I write?
Okay.
So I just wanted to explain you pore pressure and the frag pressure and how we decide for casing depths. So let's call it in SG, so it can be the density of the mud and it can be our frag gradient, pore gradient. I will have a graph here showing that, okay? And this will be depths in meter. So probably you have seen this window, we call it the PPFG window, pore pressure and the frag gradient. So it starts, let's say it will be our pore pressure. Let's have it a little bit challenging. Okay, it will be pore pressure and I will have here its pore pressure gradient and I'll have here a frag gradient. FG. Let's say for one formation, it is if it is offshore job, you will have a 58, let's say, meter of the water column, and after that it starts from 58, and you are getting here 1.2 SG for pore pressure and frag gradient starting from let's say 1.8 SG, and you need to decide that with which drilling fluid you want to drill this well. And how you will decide? First, you should have a safety factors. It will be, let's say, usually it is 200 psi. Okay, this will be PP plus and this will be frag gradient minus, right? So how you will decide will depend on these sections. And then let's choose one mud weight from here. Let's see if I can drill with mud weight till the end of this well bore. No, I can't, because in this case here I will have an influx. It is a rule, the basic rule in drilling, that during drilling, cementing, whatever phase in the drilling processes, we should be between PP and the FG. We cannot below PP because pore pressure gradient, it means that we will have an influx kick to the wellbore. And if we go above frag gradient, it means that we will have a low circulation problem. So we will frag the formation and our fluid, wellbore fluid, it doesn't matter, it is mud or it is cement. If we are pumping cement, if we are pumping slurry, it will go to the formation, and it is not, we don't want it, right? That's why we are planning this drilling phase with the casing intervals, which will depend on this graph, and I will show you how we decide. This is called the graphical determination of the casing intervals. But of course, drilling engineers use the softwares, etc. But this is the main manual option that they do in the first stage. So we take mud weight, which is secure for the beginning of the hole, right? This mud weight will be okay. We take it here, and when we are reaching to the pore pressure plus safety factor, we stop here. We cannot go below with the same borehole. We should cement till here. We should have a zonal isolation here, which will prevent fluid from one formation to go to the another formation, mixing of formations, contamination. It will prevent it. That's why we stop here, and then we are having one casing here, okay, till here. And then, okay, we are cementing this borehole, and we continue with the next section with new mud weight. We will need higher mud weight, and we come here again, we stop here because we reach our pore pressure plus safety factor, right? You see this column is not long probably, and if it is not long, we don't want to go to the surface because it is financially expensive and it will take a lot of time to run the whole casing and also to cement this casing. That's why what operation companies do, if they have such short section interval, they do liner. So we just also highlighted liner here. So that is the way we are deciding that which intervals we will have, which casing intervals, how many casings we will have, how many liners we will have. I guess after I explain this, I can go through my presentation. Now me here. There we go. A little bit faster. So I covered this section that how we decide that how many casings we will have, but we are calling these casings with specific name based on their application. Here you can see we have a conductor, surface, intermediate, and production casing. Let's define them. What is that? First one, it's the largest, it is running the largest borehole. It's called conductor casing. What is the application of this? It protects shallow formations. I said that we can have unconsolidated formations near the soil part near the in offshore, it will be in the seabed. In land operation, it will be the surface that we are walking. Okay, it is unconsolidated. It is not very. It is soft formation and it can collapse. We can have a big washouts there. Let me talk about undergauge and overgauge holes here. If you don't know, undergauge holes is that if we are going with BHOS with 28-inch diameter and you then have a caliper and you find out that okay, hole is 35-inch and this is overgauge hole, but you go with 28-inch bit, your hole diameter should be 28, right? But you find out that in some sections it is 26-inch. It means that this borehole is undergauged. So for conductor, it protects shallow formations from contamination by drilling fluid, and it helps to have integrity in unconsolidated formations and prevent washouts. So it is usually around 150 meter or 50 meter, and in most cases it's getting hammered and we are not cementing conductor casing. If it is subsea wells, probably we will need to cement conductor. But in land rigs and in deep water without shallow water without subsea completion, we don't cement usually. So surface casing. Surface casing, this is used for BOP installation, and this maintains borehole integrity, prevents contamination of shallow groundwater. So I talked about the shallow gas zones and the shallow water zones. Usually this surface casing is used till the end of that risky zones with shallow water and the shallow gas. Intermediate casing or casings, because we can have one or more intermediate casings. Usually I have seen minimum 2-3 intermediate casings. This 22-inch, 13 3x8, 18 3x8, 16.5. These are 9 5x8. They are usually intermediate casings. Intermediate casing doesn't have a specific application because it is used in all the problematic areas. If you have there some abnormally pressured zone, you are using intermediate casing. You cut that section and you are cementing, you have a zonal isolation, and then you continue with the next section. You have a high pressure zone, you have a low pressure zone, you have some hydrocarbon, small layer there, but it is not your target reservoir, you need to go below. So you are using intermediate casing, you cut that zone and you cement and continue. Production casing and the liner, this is the last one, very small diameter. Usually it is 5.5, maximum it is 8.5, 8-inch. This isolates zones above and within production zones. In this zone, you can have you will have a completion, perforation. So whatever is decided based on the well status, it will be exploration well, it will be production well, whatever. Okay, so we are having these sections, and then now we can continue with cementing, because we needed this information to understand that why we have a primary cementing. I talked about the casing sections, and these casings, when we cement annulus in primaries in behind casing, it is called a primary cementing because it is for zonal isolation. We have two main types of the cementing operations. First one is primary, second one is the remedial cementing operations. We will talk about today only primary cementing operations, and in next section I will talk about remedial cementing operations. So primary cementing operations is the cementing of casing, cementing of liner, and these ones only. And remedial cementing, it will have a cementing plugs, it will have a squeeze job for low circulation, it will have a abandonment plugs in the end of the well life where abandon the wells, and each country, each government have specific legislations for this. Okay, they are asking specific, for example, in US you should have at least in Texas you should have at least 5 plugs to abandonment. If you don't do this, you are against the law, and operated companies are usually get penalty because of that. So we are using it in well repairment if we have any problem in the well, or well abandonment. This is remedial cementing. We will talk about it in next section. So zonal isolation, one more time mentioning what is zonal isolation. Zonal isolation prevents migration of fluids from one zone to another zone. Let's say oil from production zone, it isolates oil from production zone to go above the shallow water zone, and the people all around get this shallow water in the surface are getting poisoned because we are using chemicals. We have a oil-based drilling mud, we have a condensate gas, etc. there, okay? So that's why we are using primary cementing. Till here, anyone having any question, please? Can I continue?
So far there are no questions in the chat.
Okay, so then I continue with primary cementing operations. Primary cementing operations have a lot of techniques. So there is Schlumberger, Weatherford, Baker, Halliburton, all have the cementing tools, all having the special cementing technologies. They are some of them providing chemicals, some of them providing like landing collars, float collars. I'll talk about this. There are a lot of types, but in general, 5 types of the primary cementing techniques are highlighted. First one is the basic top plug primary cementing. We will talk about this. The second one, inner strength primary cementing. It is usually used in if we cement conductor, or if we are cementing surface casing and just one below the first intermediate casing, because they are large holes and the large casing size about 22 inch. And so in that sections we are sometimes using inner strength primary cementing. We have liners, so liner cementing, top up cementing. If we have any deficiencies to get the top of cementing surface, we are using top up. And stage primary cementing in challenges formations with if we have a problem with hydrostatic. Let's go one by one. First one is the basic 2-plug primary cementing. So before the job, what we do, we talked about this. Well interval is getting drilled, right? Then we go with drill pipe, we drill, BHA, drilling team gives the well to us, and drill pipe, drill string, BHA, whatever you call it, it is pull out of hole, and then casing string is run. So we are running casing. Casing usually having a, I haven't put it here, but okay, no, it is here, float shoe. What is float shoe? We have a float shoe, we have a shoe in the casing shoe in the bottom of the casing. It facilitates the running the casing to the borehole because it is guiding it. So that's why there is a guide shoe and also float shoe it is called. It helps us not to get stuck, because if you have a very flat casing ending, it can get stuck in the hole, but it is directing the case, this shoe. So casing is run till the shoe, and this is called the shoe depth, the end of the end depth that you want to run this casing. Then well is circulated out with mud weight, pre-job circulation. I already talked about this in the terminology part. Sometimes why I put in the bracket seawater in the first sections, conductor, surface casing, and very rarely, but sometimes in the first intermediate casing, operators are using seawater because pore pressure and frac pressure gradients are very low. So you cannot go 1.2, 1.3 SG mud because your frac gradient is 1.3 SG. That's why you are using seawater or sometimes weighted seawater. Yeah. this kind of drilling fluids we are using. Well is circulating, and we are sure that the well is clean from any cuttings, any debris, and now we can start cementing operation. How we cement? We have a casing. Through the casing, we are just pumping through the casing in the 2-plug primary cementing job. These plugs are very important. They are called the top plug and the bottom plug. You can see these green ones, top plug and the bottom plug. First, what we do, we have a bottom plug. We are pumping this before the cement slurry, okay? But before that, we are pumping spacer. Spacer, as it names stands, it is, as its name states, that it is spacer. It has a spacing effect between mud and slurry. Most of cases, slurry and mud is incompatible. That's why we don't want them to mix, because then slurry will not get hard cement properties. We will talk about this in laboratory testing section. That's why, just very common stuff, we do a lot of simulations. Softwares are available in each company. We don't want mud and slurry is getting mixed in bottom hole. We are trying to have a space. In Azerbaijani, they call it buffer. It has the same meaning that it provides space and it doesn't allow, actually it prevents complete contamination of slurry with mud. Okay, that's why first thing we are pumping is spacer. Usually in first sections, operators doesn't want to pay for it. It is kind of expensive. They are asking to pump some seawater before cement slurry. It's also okay. It will have some buffering spacing effect. After we pump spacer, we are pumping bottom plug. It goes first, and we have a float shoe and float collar in the bottom, right? So float shoe, float collar are the main types of the shoe and the collars. Why? Because it is more it is mainly used because they have valves inside and shut-in valves, and they don't allow fluid U-tubing actually when we wait on cement. We are pumping slurry. Slurry is setting in the annulus, but while it gets hard, it gets solid effect. This can have a U-tubing. It have a U shape when it comes from annulus inside casing. That's why it calls the U-tubing. We want to avoid U-tubing because we want slurry to be kept inside annulus, not inside casing, right? That's why these float collar and float shoes are mainly used. They have a valves, doesn't allow, like one pass valves, and they doesn't allow U-tubing. They only fluid can come down but cannot come up. Okay. That's why first we have a float shoe and the bottom plug is going and they set in the float shoe first. After spacer, we put with cement head, we put the bottom plug, and then we are pumping slurry, and we are launching top plug, and then we are displacing slurry with mud or any drilling fluid, whichever is in the well or will be used in the next section. Okay, so this is cement head. This is very conventional one I have put here because there are a lot of types used for deep water cementing and other applications. I just took it from internet because it's very conventional. First model has been used. This one have 3 valves there. How they use it? First valve in the below, it is always open while we are pumping spacer, and between these two there is a space that bottom plug is placed. So when you pump spacer from the first valve while it is open, then you close it, then you are starting to open second valve, and you are pumping through this second one, and at this time bottom plug here in the middle will go down, and you have a top plug here. So then you pump slurry from here, and then you close it, and you are pumping from here, and it will make top plug to go down and after slurry. So in this case, you are separating slurry from bottom and up. Okay, you have a 2 solid plug, you have a 2 solid separator. So it will prevent contamination of slurry. So top plugs, bottom plug has a rupture disk. So when it goes, you can imagine that this is a solid and it goes down, it sits in the float shoe. But how this slide is going to analyze, because it has a rupture disk. How this rupture disk getting ruptured, it is because of hydraulics, because we are continuously and it will have plug, it will come to the also collar and they sit above the bottom plug at the end. And when we saw that while displacing top plug is sitting the bottom plug, we are getting pressure indication in the surface. In cement unit, we saw that, okay, pressure is up. It means that the top plug sitting on the bottom plug. And before the bottom plug, we have a float shoe, okay? These are sitting in the float collar. And between the float shoe and the float collar, we have some space. We are calling it shoe track. Shoe track is, we are keeping some slurry in there. And in the next, before we start next section, we will drill and then we go to the next section. Why we are having this? Because while we have a wellbore integrity, we are talking about zonal isolation. At the same time, we should talk about shoe integrity. And when we try to drill next section, we don't want any migration from previous section, okay? We don't want any fluid comes down. We don't want any pore pressure from there, any influx. That's why we should have a good shoe track integrity. Only thing I haven't talked about here is centralizers. Centralizers, as its name states, again, it is centralizing casing. Before we run the casing, drilling team just put the centralizers in each joint or each stand. So stand and the joint is the parts of casings, how they connect them, okay? Three joint is one stand. One joint is around 9.6 meter. It can differ for each casing spec, but usually the average number is 9.6 meter. And one average stand is around 28, 29 meter. So in each joint, in each 9 meter, we are recommending to use at least 1/1 in each joint, to use one centralizer. Both spring centralizers are good for open holes. Rigid centralizers, it can be used inside casing to casing, because these both spring centralizers are getting enlarged, and when you have some narrow space, they can have a smaller diameter, okay? That's why this is good for open hole. When you have a washout, it have a maximum diameter and it can get extended, enlarged, and it can give you better centralization. Why centralization is important for cementing job? Because we are pumping slurry and it goes to annulus, right? If we have this casing in the inclined part of the well, if we have a high inclination, and this casing will lie on the formation, will lie on the wellbore from one part, and another part will be free. And when we have a slurry comes around this casing, it will go only from one side, okay? It will bypass, it will not have a complete 360-degree zonal isolation, because slurry will be only one side. And that is the indication of the bad cementing job. That's why we need good centralization. Casing should be in middle, and the slurry should cover it from outside. Yes, I guess this is all about basic to plug primary cementing. Plugs are very important to avoid any contamination between slurry spacer, slurry mud. Any question from here? Because we will complete this section and I will move to another cementing technique. Is everything clear?
Just I have.
Okay, just please ask.
How we enter the top plug? Is this part of like what to say? We pump drilling fluid. How we can pump plug?
Okay, how you can pump plug? Plug is going through the cement head. The application of cement head is to launch the plugs. It is also sometimes called the plug launchers. Okay, so as I showed here, you have this cement head, and previously, before you put this cement head, you connect this cement head to the casing, top of the casing in surface. You are already adding placing plugs to here. First plug, bottom plug will be here between this first and the second valve, and top plug will be here between the second and the third one. And while people cement head operators on the rig just cementer calling them, okay, I pumped already spacer, you can launch the bottom plug, and they are opening, they are closing first valve and they are opening second valve. So they are pumping through second valve, and the plug between these two valves just pushed down. Okay, and the same for the top plug. Could I answer?
Okay, thank you. I understand.
Okay, welcome.
There is another question in the chat.
Yes. Okay,
so it says, okay, I can read if you want.
Yes, please.
So how many hours it takes for cement settling?
How many hours for cement settling? Better cement settling or cement getting compressive strength? Yeah, and you mean the cement getting solid, right? Probably because cement settling is something, a property that we don't want it happens, because cement settling means that in slurry, these solid parts go down and we have a water in the surface. This is the property that we don't want to happen. But for cement to get compressive, slurry to get compressive strength, it depends on the chemicals we are using. In the lab test, we will talk about this. We are doing UCA test, which is ultrasonic compressive strength test, ultrasonic compressive strength analyzer. I will put the photos and some videos maybe I will take in our lab, and I can put in the next sections to show that how we did test it. And before the job we analyze, okay, mostly we need 500 psi compressive strength to drill, just to get it okay, to get it solid hard cement there. Okay, this 500 psi, it is usually around 12 hours, 24 hours. It really depends on the cement slurry recipe, because we are adding some retarders which are extending thickening time. I will talk all about this, but if someone having information, just answering to that person. So we are using retarders, and these retarders extending thickening time. When we have longer thickening time, it will also affect to the compressive strength development. That's why it depends. We can't say how many hours, but usually we wait at least 24, 36 hours before drilling next section. Was it clear?
Okay, thank you. So there is a question regarding the recording. I just want to mention that we started recording, but if our speaker will not be against, we will share recordings in the end after 5 weeks. If you attend those 5 weeks webinars in the end, and if our speaker will not be against, we will share.
I'm not against. I'm okay with that. You can share, Rahima, at the end after 4 or 5 weeks.
Yeah, thank you.
Welcome. Can you list that company for cementing? You mean the companies, service companies for cementing job? I'm currently working in Schlumberger. We are having cementing services like Baker, Halliburton, and in US there are very small service companies. They are providing cementing services. But the largest companies, service companies, first one is Schlumberger, then it should be Halliburton, Baker, and others. In Azerbaijan, currently we have, I guess, bigger share, and then Baker should have. Okay, another question? You are welcome. Any question?
I think for now there are no questions, so we can continue.
Okay, then I will continue to present. I'm sharing screen and okay. So if you understood this primary cementing operation, it will be very easy for you. Just to be, if you will be in the interview for cementing engineering, it will be very easy for you to explain this stuff. Because when I started in company, I didn't know any of this. Okay, I just knew how to calculate cement slurry volume, required cement slurry volume, and I will also teach this in one of the sessions. Okay. And then now you can visualize here how the cementing job is done. I explained somehow, but you can see that arrows, okay? We have a drilling fluid in the first case in the well, and now circulating drilling fluid. So we have here float shoe, and this is float collar. You see valve here mentioned in there as a round, let's say, shape. Okay, this is specifying that there is a float collar here. This is centralizers, makes casing in the middle, doesn't allow casing to lie on the annulus over the formation, over the wellbore. So we have an annulus, we have a casing string and drilling fluid. So now first, before we start to cementing the well, to pump slurry, we are circulating drilling fluid. Why we do this? I already mentioned, to get BHCT, bottom hole circulating temperature, to take all debris out, to take all drilling cuttings out, and to have a clean well to cement. So pumping, wash, spacer, cement slurry. I didn't mention about wash, but we have spacer, and wash has the same function. Sometimes before the spacer, we are pumping a little bit cheaper fluid, usually chemical wash, seawater with some chemicals, okay? So this is also separating spacer and the slurry, spacer and chemical wash, spacer and the mud, so it will not allow these fluids are getting contaminated while we are pumping. So chemical wash is pumped, spacer is pumped, green color, and then there is bottom plug. Then there is cement slurry, so these are pumped. When you have a bottom plug reach to the float collar, you are displacing, you have a top plug here, so it means that now your displacement fluid should be reached to the float collar for you to complete the cementing process, okay? Displacement starting, top plug is coming down, bottom plug is already sit on the float collar, and when this top plug also come and they sit over the bottom plug, your job will be completed. So you will have slurry in annulus, you will have slurry in shoe track, and you will have a bottom plug and the top plug sit over float collar. Okay, you will have zonal isolation in annulus because of when this slurry is set, and you will have a good zone shoe integrity when you have this slurry between shoe and the float shoe and float collar are set. Okay, for primary cementing, the second one is the inner string primary cementing. Inner string cementing. So we talked about conventional cementing jobs, but conventional cementing job, we are using two plugs and we are pumping through casing, right? We don't have any tubing, we don't have any drill pipe. We are just pumping through all this casing. However, when we have a very big, large holes and very big casing, like let's say 36 inch, 30 inch, 28 inch. So in this one, we will need largest displacement volume. Sometimes it is 1,000, 2,000 barrel. And when you design a slurry, you need to add some chemicals to retard cement to get set. Cement should have enough thickening time before you complete the job. Okay, that's why this conventional cementing method is not very good for large casings and the large holes. There is a new technique used, not new, it's a long time it is used, inner string cementing method. conventional method had problems like large displacement volumes, long pumping times. You are displacing for 10, 12 hours because of 1,000 barrel, 1,500 barrel of displacement volume. So plugs can stuck in casing due to their large dimensions. Now you need to have a plug for the 28-inch. Solution is an inner string method, no cement plug is used. How this happen? You can see one big picture here that there are drill pipes, right? Drill pipes are going and connecting on the special float collar. Okay, this is not the conventional one. And you can see that there is a two joint adapter and you have a sealing adapter. They are connected to the sealing sleeves, and so through that drill pipe you can pop slurry and it will directly go to the annulus. Before it was in the conventional model, it was going inside casing, and the casing wall was already getting dirty by cement slurry, right? But now you will not have any interaction with casing inner section. It will just slurry will go through this tubing directly to the chute, and from chute to the annulus. It is called inner string cementing jobs. It is only used in large casings. Okay. If any question, I'm waiting for it. If no question, I will continue with liner primary cementing and top-up cementing. So liner cement is having any question? I heard something. Okay.
Yeah, there is one question.
Yes.
If there are any fracture in subsurface during cementing operation, what are action taken that time?
Okay, just let me read the question here. It's if there is any fracture in subsurface during cementing operation, what are actions taken that time? So subsurface during cementing operations, actually we shouldn't have, because it should be calculated, it should be simulated before, and my job as a cementing engineer to be sure that we are not exceeding frac gradient, okay? And if this fracture is happening when we are above our EC, the equivalent circulating density is above frac gradient of that formation. So first, it should be prevention. There should not be any mitigation. We should avoid this. But in some cases, it cannot be avoided because frac gradient is very low and the pore pressure frac gradient window is very narrow. In that cases, if it is the surface casing, we are getting top-up cementing, and I will talk about this. Sometimes you are getting, like when you are cementing 28-inch casing, you are getting fracture, and the sum of this slurry is lost to the formation, right? And you will not get top of cement at the required depths because you wanted to see slurry on the surface and to cement this annulus till the surface, right, for surface casing. But in this case, you will not be able to, because this slurry will be lost to the formation. What we do in this case, we do top-up cement. I will explain how we do this. But if it is if this section is below, if it's liner, if it is other intermediate casings, sometimes perforating and the squeezing slurry is an option. But if this zone is very critical to be cemented, then we can do this. We perforate, and sometimes staging tools are used to avoid this fracturing effect. I will talk about the stage cementing. So first action should be to prevent it before the job. Use the different technique not to have a fracturing. But if you have a fracturing during the job, non-estimated, then if it is surface casing, you are using top-up cementing. If it is intermediate casing and if it is liner and client requires that we should have a good zonal isolation, it is very important because in behind you have a shallow gas zone, shallow water zone, and they don't want to have any inflow, then perforation and the squeezing cement can be an option. Yep, that was my answer. Another question before we continue? String. I guess it should be boru, right? It should be boru. Yeah, string should be boru. I don't know another version. Okay, you mean meaning, not translation. String is bu bir borudur. Boru içindən bizdə vurulur. Slari borunun içindən. Yəni boru turba da belə deyə bilərəm. Başqa bilmirəm necə izah edə bilərəm ona. Misal üçün drill pipe'lar var bizdə. Drill pipe'ın özü stringdir. Qazma borusu. Belə deyə bilərəm. Rəşad, ümid eləyirəm aydın oldu. Çünki başqa bilmirəm borunu necədir. You're welcome. Okay, another question? Okay, then I continue because I guess we are run out of time. Okay, let's go back to presentation. So we covered inner string method, and now we can go to the liner cementing. In liner cementing, I talked about liner hanger, and in this case, we want to have a good isolation till the liner hanger. Okay, we will cement annulus, and also we will cement the liner overlap. Now, how we do? Because in conventional cementing, we were pumping through the casing, and then it was going to shoe, and from there it goes to annulus. But now we don't have connection between this top of liner and surface. In this case, what we do, we are using drill pipes, again strings. So these strings are connected to the liner hanger. How a liner is running, you should know that liner is going to be run with setting tool, with the end of drill pipe, right? So liner hanger is setting the setting tool, and then this is running to the depths, required depths, and drill pipe is getting rotated, and it will set the liner hanger. Liner hanger, its name states that there is a hanger. It's getting hanged from the previous casing. It has some sleeves, and it is getting hanged. After liner hanged, you have still drill pipe there, right? Pipe to the inside liner, and from inside liner, it's going to the annulus. Float collar, float shoe, these are the same what we had in normal casing, only top part of the liner hanger part is different. And in liner hanger, there are a lot of tools the service companies providing, that the liner hanger with two plug system, with one plug system. We can have a top plug, bottom plug, but we know that the top plug, bottom plug, they have a sizes of the casing inner diameter, right? To have a proper wiper effect, to clean the inside casing and to wipe, slide it down, right? But in this case, how I can pump, let's say 8-inch plug through 5-inch drill pipe. So for liner hanger, it is different. You are not sending plugs from surface. When you have a setting tool is going down, under setting tool, you are top. If it is two plug system, you have a top plug, and the bottom plug is already placed there. But if it is one plug system, you will have only bottom plug in that, okay? Sorry, you will have only top plug. If it is one, only top plug is used. But how to launch it when your slurry reaches there? For this one, darts are used. I have put the photo of this picture of this dart. Dart is very similar to the plug, but it is kind of launcher, and it has a smaller diameter. So in liner operations, liner cementing, this dart is getting launched before the slurry and after slurry. It goes to the liner hanger setting tool first, and it launches the plug from liner hanger. So plug is the same with normal casing I explained in conventional cementing starting, and this bottom plug starts to move down, then slurry, and then another dart comes and they launch the top plug, and you are having below the liner hanger, you will have a normal conventional cement I already explained through casing job, okay? And the second technique I would answer the question I have got about if you get any low circulation in subsurface and you don't get top of cement on the surface. You see in the pictures that the top of cement here is in the surface, right? It's still this green zone. However, sometimes here information we get we are going above frac gradient and we start to lose everything we are pumping to the formation from these depths. And it means that slurry will not go up till surface. So what we do in this case, and we know that it is very important sometimes to have good zonal isolation in this zone because it is unconsolidated formation. It can collapse, it can have washouts, and it can be difficult for us later on. That's why we want to have a good zonal isolation. What we do, we are using, sometimes it is called the spaghetti method, and for spaghetti method they are using 2-3 inch very small diameter tubings. They put it in annulus and they are starting to pump, we are starting to pump through annulus. So it is not very common, but sometimes we have used it, okay? We have the top up cement. It is, so these tubings are going to the depths where top of cement has found from logs, temperature log or any other log was run. And they found that, okay, top of cement is here, but above that there is no cement. Then what we do, we take this tubing and we place it from annulus in that depth where we don't have cement, and slurry is pumped and circulated out around this tubing, and top of cement is going to be at surface or somewhere near surface. This is called the top-up cementing. Low diameter tubings are used, and sometimes it's getting called spaghettis. Last one will be stage primary cementing. Before that, any question about liner cementing and top-up fill? So no question, I guess, right?
Yes. So far.
Okay, then I am continuing with presentation. So next one will be, okay, where I left it. Okay, this one will be about stage primary cementing. And the question about getting fracture information during cementing job. Yes, we know before, right? We know what is our frac gradient, and we are simulating. We have a lot of technologies make it available possible to simulate and to find out what is the equivalent circulating density, and if we will frac that formation, if we are in safe zone, okay, we can identify it beforehand. And when we saw that, okay, there is no way, if I am running a whole string and if I will need to cement it to pump slurry till the surface, then I will frac formation and I will have lost circulation. It will be lost to the all slurry, will be lost to the formation. If it is production zone, it is very bad because formation fluid, that reservoir fluid, will get contaminated and you will get mud and oil mixture in the surface. And then when you deliver this well to the production phase, they will always complain that, okay, we don't have our formation, our reservoir has been disturbed. So that's why we don't want it, right? We don't want to have any fracture in the job. And when we see that, okay, it is required to have a long string to be cemented till the surface, but frac grading doesn't allow. Hydrostatic pressure is exceeding fracture pressure. In this case, there is a technique, multi-stage primary cementing. Multi-stage, usually it is 2-stage, it's called multi-stage, but most common one is 2-stage. Here in Azerbaijan, there are a lot of applications, and I have been in 2 jobs with 2-stage cementing. I have been on the link during cementing job, and I will explain you how exactly it is done. Yes, first, there is a special setting stage tool, okay? This is when casing is run, it is in one of the joints that you want the primary first cementing jump to be done. You can see that the stage tool in red, okay? It is in the middle, I mean, in the depths that the client wants to first cementing done and second stage cementing is done, okay? Just whatever they want. They are identifying that depth and the stage 2 is installed before running casing. And it is getting run to the target depth. First, as a liner, so in liner, top of cement is in liner hanger, right? Job is behaving like a normal liner job. We are pumping through that. We are cementing the annulus till stage tool. Okay, and then we are waiting for 24 hours, 15, 16 hours. It will depend on the lab testing. And we wait till this slurry lose its hydrostatic and it's getting set, it is getting hard. And in this case, we will not have any when we cement upper section, we will not have any hydrostatic effect in the formation below, right? There will not be frac gradient because this is already solid in bottom and it will not pass this hydrostatic. So then then there is balls. Sometimes it depends on the provider manufacturer. Sometimes there is a wall, the setting tool is, sometimes it's hydraulically open. Sometimes we need mechanical initiator launcher to open this setting tool. So this turn around, and there is flow areas in this setting tool. When ball is going and open that flow areas, now you can make a circulation from that depth. You don't need to, you don't need to pump down because you have shoe there with slurry, and now you can have a circulation in upper part. You see this blue arrow in the second picture in the right hand side, second stage. You are making circulation and you are pumping slurry for the second stage. In this case, if you had a chance to frac previous part in the first stage, if you had a chance to frac, now you have isolate hydraulics on there. You will not have any hydrostatic effect there, right? You will not frac it. So this is how multi-stage primary cementing job is done. Yes, any question also from this technique? I'm ready to get questions, and I had some calculation part, but I think that we are already running out of time. We have already 1 hour and a half. So that would be better if we keep this calculation for the next lesson. Next section. I will explain calculation on board. I will write down and show you how to calculate slurry volume. And this will be a topic in drilling engineering, in petroleum engineering. If you are studying in Baku High Road School, we have this, and in your exam, drilling engineering exam, probably you will have this question to calculate required slurry volume to cement. They will provide top of cement, they will provide ID, inner diameter of casing. Probably they will provide SG or PPG as a density of fluid, and they will ask you some pressure calculation and some volume calculation. I will cover them in one of the next sections. I guess next one will be remedial cementing and cementing equipment, and third one will be about this calculation. Yes, or maybe second will be a calculation. I will decide on that later on. So I'm ready to get any question from starting, and yes, then we can complete this section.
Okay, thank you very much. There is so far one question in the chat.
Okay, let me check. I can check myself. Thank you, Rahima. If there new technology using for cementing operation, so which using for cementing? So the question was not clear because each company have a lot of new technologies. Currently, I'm working in Schlumberger, and we have a lot of new technologies for cementing chemicals used. We have a new technology for cementing equipment tools. No, not calculating slurry density. How we choose and calculate slurry density. Okay, for first question, I'm not sure if I have answered this. New technology using for cementing operation. There are a lot of, but for these techniques, they are common techniques that I talked about. Like these are already proved and applied in a lot of locations. So next question, how we choose and calculate slurry density based on what? We are choosing based on the simulations that we are done, and it is the same I explained here for this graph, this pore pressure and frac gradient. So we are taking a slurry density, which is of course will be above mud weight, mud density, but at the same time, our ECD when we are pumping this slurry, if there is no simulation, please. Okay, if there is no simulation, actually, then you are calculating hydrostatic, but it will not be representative, because in this case you will do only static. You can choose some checkpoints and you can take some slurry densities, and based on that you can have depths, and you can have columns of slurry, spacer, mud in checkpoints, and you can calculate and check if you are exceeding frac gradient, but it will not be representative information, because you need dynamic simulation to see that what you will have as a equivalent circulating density. Otherwise, I know in some companies, especially in Azerbaijan, they don't have simulators, but in big companies everywhere we are using simulations. Otherwise, I can't imagine that it will be possible to have a safe job. So slurry density is based on it should be above mud density, ECD, and pumping speed. How we choose pumping slurry speed without any simulation? That is very tough question for me, because I haven't done it without simulation, and actually in our companies it is not acceptable to pump any job without any simulation. So pumping speed, when you are pumping with higher rates, you are getting higher ECD, okay? Because this circulating density will be above when you pump with higher speeds. But actually, we have limitations for pumping speed based on the equipment. Okay, based on the equipment, I'm getting next questions, but let me ask in previous one, which is pumping slurry speed without any simulation. Yes, you can have a range. That will be maximum one, will be a limitation of equipment. Most of the units cannot pump, cement units cannot pump above 8 barrels, 8.5 barrels, because of the lines IDs and the line specs doesn't allow for that. So you can be between 8 barrel and for good mud removal, you will need at least 3-4 barrel per minute if your frac gradient allows. Okay, you are doing a lot of jobs without simulation, but my job is to do simulations. That's why I haven't done any. Sorry, I don't have any experience to have any job without any simulation. So as a design engineer, my job is to do simulations and decide density of slurry and other fluids based on this. Could you please share your experience with the application of top-up cement jobs? We have small diameter pipes running hole from analyst. How we run it? Is there a special tool that should be installed surface for running these small OD pipes? So for this one, actually, I mentioned about this. It is mainly in the surface part. Okay, in the surface casing, you don't have BOP. No, sorry, for conductor casing, you don't have a BOP. That's why it will be open, and I'm not really sure how operating companies do this. We are not providing these tools as a cementing company. So this top-up and all the installation is done by operating company. They are using 2-3 inch pipes, and they install. We are just connecting this to cement unit, and we are pumping through that. Our special tool. Our cement unit can be connected to this or this, like they have some crossovers over that, and they can use it. Yep. Any other question?
So there are just no questions. Does anyone have any questions? So you can unmute yourself and ask as well.
Yes. So just let's wait for one more minute, and if there is no more question, I guess we can finalize it today. I need to move to my meeting.
Yes,
Yeah.
sure.
Okay, thank you very much, everyone. Someone just joining? Is there another session starting right now, or?
No, we will post like before the sessions on Telegram. So please, everyone, join our Telegram channel to stay updated. And I want to say huge thanks to Munavvar for an amazing session. Thank you for your time and answering all questions. And we will meet next week, next Saturday, and we'll continue with this topic. So we'll send you emails about the exact time and also post on our Telegram channel. So please follow us, and thank you again, Munavvar.
You're more than welcome. I'm happy to present, and see you soon in the next session. I have the new information, new knowledge for you and you guys from here. Yeah, thank you very much for joining, and Rahim and the whole SPE team. I have been in SPE team in SPE chapter in Baccalaureate School previously when I was a student, and I'm really happy that I was invited and I'm here. Thank you for invitation. Thank you guys for joining. Bye-bye.
Yes, thank you very much. Goodbye. Goodbye, everyone. Thank you for participation.